So the case study, I wanted to go through this, and I'm going to hand out the, this is the first case study here on the screen. I'm going to hand out the template for you guys. So this is a Word doc posted to Blackboard. I'll show you where all this is. It's the same analysis that will be used for every single case study we do. So regardless of what the PDF file is, the same case study is used every time for analysis, because we just go through the phases. Now, not every case study is going to document things the same way. So that's why I wanted to pull this one up as an example. Can you guys see okay? Do I need this one on? Well, thank you, Hunter. That's very generous of you, but I actually was more concerned about whether or not you can see. Okay, so looking really quickly at the case study analysis, you can see here that the first thing we're looking at is what is the overall purpose of the project? And that will be in the abstract of all of these cases, or in the very first paragraph. But what we want to make sure that we're clear on is what issue were they trying to address? And then we're going to work through DMAIC to analyze this case study. Part of the reason that we're doing these very early in the semester is because you are going to document your project using the DMAIC method. So these case studies are a model for how you're going to proceed. And so it helps you to look at how do you document everything in each individual section. Your answers do not have to be extensive. If you did 471 with me and you did case studies there, like, this does not have to be a novel. This can be just a couple sentences to answer each of these questions. So this document should not explode into like 5 or 6 pages. This should be probably 2 to answer. I mean, it's like 11, 12 questions. So it'll probably go into 2 pages, maybe onto a 3rd page, depending on like what font size you use and what spacing you use and how verbose you are as an individual. But this is not meant to be an epic undertaking every time I give you one of these. And the goal of doing these case studies, again, is to teach you how you are going to document your own stuff. So it's a model for you to follow. So define phase, primary stakeholders, key performance indicators, or critical issues. And we'll see as we go through the lectures, things might be critical to quality, critical to cost, critical to delivery. There's a couple key metrics that are pretty standard across various industries. If you're looking at supply chain, it's much more on the logistics end. If you're looking standard business, a lot of things are critical to cost, critical to quality. If you were doing something like in the grants office, those were all time-based. We were trying to shorten the time that it was going to take. So everything was critical to schedule. Those were the metrics that we were looking at. So depending on what your project is, will determine which of these are used. And then the key performance indicators could, again, be matched to that. The language can be used kind of interchangeably depending on where you are. KPIs are pretty standard for large industries because they use these for everything, not just Six Sigma. These are just their business definitions. So KPIs could be a quality metric, percent quality, out the door quality. They could do internal quality metrics. Again, they could do adherence to schedule, uptime, downtime, maintenance time, labor hours, overtime hours. Like, there's a lot of different key performance indicators, again, depending on the industry and the process that you're looking at. So your project will have these identified based on what it is that you're focused on. What are we actually trying to improve? And an improvement can be reducing, right? Reducing errors is improving quality. Reducing cost is improving profit, right? It's kind of the inverse. Like, you can state things as an improvement or as a reduction. Either way, we're making it better for the customer, for the company, for the system. So that define stage is pretty simple to find in these case studies that I've selected. It's really clearly identified. Measure, so what was measured, how was it measured, how did the measurements relate back to the overall purpose or KPIs? This is you checking them. Are they looking at what they said is important? Are they looking at what is supposed to matter? sometimes you're going to see that they look at some other things that aren't connecting to the KPIs. And the question is why? Is it because it's a nested process? Like if you have multiple steps in a sequence and you're trying to improve out the door quality, there might be several workstations that have quality issues within this facility that you need to address to raise that out the door quality. You can't just say at the end, I want the end product to be better. You have to look at all the steps that go into the end product to make the end product better. So sometimes they're nested, sometimes they are required, and sometimes they're not. Sometimes people just like measure things to make it look like they're busy or to make it look like they're working. That's not actually helpful. So you get to look at that. And then going into the analyze phase, what methods of analysis were used. So these might be lean methods, these might be statistical methods, they might have control charts, run charts, you know, depending on the process that they're looking at, this could be very lean oriented or this could be very Six Sigma oriented. That's where that lean Six Sigma, like there's places of overlap and there's places that they kind of diverge. So if they're using a fishbone, if they've done a 5Y, what they're looking at is kind of in the lean toolkit. If they're taking a run chart and they're doing a CPK on it, they're going kind of the statistical method on it, right? They might be doing a combo platter and grabbing from all different pieces of it. That's why it's Lean Six Sigma, is because you can do that. You can grab from multiple places. So you're going to look to see what they're doing and then look for the improvement phase. What improvements were made and how did these improvements relate back to the KPIs or those critical issues? I can't tell you the number of times that I've read through these case studies and they talk about an improvement, but it wasn't actually the goal because their project didn't actually work. They improved something, but not the thing they set out to do. Now, an improvement is an improvement, right? We made something better. It wasn't a waste of time. But you have to go back to your stakeholders who wanted you to solve X and say, yeah, we didn't solve X, but we solved Y. Aren't you happy? So there are times where as they dig into the project, it's not really reason they're not going to be able to get it done. It's not all within their control. You might come down to a supplier issue and the supplier tells you, nope, not doing that. And so your idea of having JIT is not going to work with that supplier. You can change suppliers, but that's a lot bigger project and a different process and different people. That's not really in your scope. But maybe you were able to change some things internally to help the flow better, even without going to JIT from the supplier end. So I didn't do X, which is what I said I would do, but I did Y, and Y is good, and Y helped. So it doesn't always mean that like it's a complete failure, but some of these projects, they don't do what they set out to do. So then control. How are the improvements and changes going to be controlled? How is this documented? Who was responsible? If they're not labeling responsibility, I have a very low confidence that they're going to be maintained. How many of you at work have seen like some sort of improvement of any kind be initiated? Or just even in your home life, like your roommate says that they will do their dishes regularly and like they do it for a day and then they don't anymore. When there's no accountability, when nobody has a reason to sustain that change, those changes often drift back to the previous state. And we're actually going to talk about that today. That's the focus of today's lecture. So control, and then overall, these are just looking at it as a whole. Did the project accomplish what it set out to do? And then finally, what thoughts, questions, suggestions do you have when reviewing the case? This is what I want to hear from you. Like, why didn't they do X? I would have done Y. This case is confusing to me. I have no idea what they were talking about. Like, you can write whatever you're thinking there, but I do want to see what you're thinking. So this helps give me a barometer. Again, this is happening early in the semester. This helps give me a barometer on what are you understanding? What do you need help with? So like, you can even say like, they did this statistical analysis and I couldn't follow it. Tell me that, because that tells me what I can work on in class as well, what I can hit a little harder. So as we go through this, please make sure that if you're seeing things that you don't understand, if they're using words that you don't understand, if they're using terms for improvements that we haven't talked about in class and you don't know what they are, list them. I know a few of you have less professional experience or less like curriculum experience with these concepts. Don't pretend you know everything. Tell me. Tell me when you don't understand what's happening. Tell me when a term is unfamiliar. Tell me when you're like not feeling comfortable and confident and I'm moving the rest of the class on and you don't feel like you're ready yet. I'm not always going to be able to address it in the classroom, but you and I can schedule a one-on-one over Zoom or in my office to go through that in more detail so that everybody, by the time we get to the certification exam, everybody's in the same place. That's my goal. So you might not all be starting from the same place, but there's no reason we can't all get there together. So just let me know. Okay, so looking at a PDF of the first one, this is your BRICS case study. And so when we look at this, so this was done internationally. And so actually from South Africa Journal of Quality and Process Improvement. So when you move down here, you'll see in the introduction, they start out by going through some background of why they're doing what they're doing. Then they say what the problem is. That problem should be answering 1, 2, and possibly 3. They give you some data that was done. They give you some background, talk about some lean. They go through their proposal. And then look at this. There's a reason I chose this one. They give you define, measure, analyze, improve, control right there. So they walk through the DMAIC process in the literature and they actually explain how they did what they did before they get to their conclusion. So you should be able to walk through the DMAIC process for the case study analysis with this document really clearly. And that's why we're starting with this one, because it's a process that they mapped directly to DMAIC. And so we can walk through it using this analysis. One of the ones that we'll be doing, it's a little less clear. They did all the steps. I read through it and they did all the steps. You can answer all these questions, but it's not as cleanly laid out as this paper is here. So I wanted to start you off with a high degree of confidence in yourself. When you look on Blackboard, the case studies are already all posted here, the template, the Word template, and then the 3 case studies that we're going to work through. They are posted again in week 4 where the submission is actually due. So the Word document and the specific case study, the Lean Bricks case study that we're working on, are both here in week 4. So you have it 2 different places. You can see where we're going to be getting that material. And if you forget the one, you can go to the other. All right. Questions on that? Okay, so yes, Josh. So because I gave it into a Word document, you should just be able to type. So under 1, type the answer to 1. Under 2, type the answer to 2. If it says like, what's the KPI? You can just say quality. That's okay. If they have a target metric of like 93%, I'd like you to say that as well. Like KPI is quality. They want to hit 93%, right? Like give me the information, but you don't need to write a paragraph if a paragraph isn't necessary. Now, the places where it's like, how did they measure this? What did they find? That's going to be a little more extensive, but some of those initial questions are probably pretty straightforward and don't require a huge answer. Who's the stakeholders? For that one, it could be the operators. It's an improvement on the process of how they actually do it. The operators are the key stakeholders, and the customers. Customers always a key stakeholder, right? Like, so 2 words answers that question. Some of you will choose to write those 2 words in a very nice paragraph explaining why that's so important and how they came to that conclusion. Some of you will write those 2 words. because you guys are different and I've had most of you before and I know how you guys write. So like Leo's and Kyle's will not look the same. Okay, any other questions? All right, so chapter 1, Six Sigma. When we look at a normal chart, a bell curve, we understand from statistics that in a normal distribution, 1 sigma out is plus or minus about 68%, 67.667. We understand that 2 sigmas out is at 95%, and 3 sigmas out is at 99.7%, which sounds really impressive until you realize like how large that can be per million opportunities. That's like hundreds per million opportunities. So if you don't want your plane crashing or being sent home with the wrong baby, like these are things where you know, 3 sigma is not necessarily enough. 6 sigma is 3.4 errors per million opportunities. And the textbook actually goes through how that terminology was decided. It was Motorola who created the 6 sigma process and kind of determined based on customer consumption, the life of the product, those types of things. That's how they made this arrangement. But we're looking at 3.4 errors per million opportunities. Now, if you're thinking of a life or death situation, I still don't want to be part of that 3.4. I always want to be the part that doesn't have the issue. But to just illustrate how far out along that line, you know, from what we say a normal quality process, because the original total quality management perspective looked at the bell chart. They looked at that 3 sigma level, that 99.7% as a quality metric. And so the 6 sigma process leads to this 3.4 defects per million opportunities through a structure. There are multiple of these structures. We're doing DMAIC. There's also DMEDI, which is for a research-based opportunity. So you're not necessarily looking for the same outcomes in research situation. And DMEDIV is used like in logistical settings. So different industries have tailored this slightly to their own needs. But basically for any process improvement that is a executed process, because like research sometimes can be a thinking exercise, right? It can be harder to define and control something that's happening inside someone's head. I think every parent ever has tried to control what's happening in their kid's head and it doesn't work. So you can't necessarily do this the same way. DMAIC is made for any process that you have some sort of tangible output, some sort of measurable output. So define the goals of the improvement activity. What are we setting out to do? Measure the existing system. And these are written in the most broad terms. We'll break all of these down over the course of the semester, along with the tools that we use to accomplish these tasks. But the define is really what's your problem. Measure is what's the current state. How are things operating right now? Analyze the system to identify ways to meet the desired goal. Now, this analysis is where we see that Lean Six Sigma combo platter happen, because sometimes we're going to use like a fishbone, a 5Y, an affinity, a brainstorming, or we might do a SIPOC chart, or we might do a control chart, or we might do a run chart, right? So there's a whole plethora of tools available to us. We have to look at the specific situation and pull the right tools out that give us the best data to work with. There's a saying, when all you have is a hammer, everything looks like a nail. When you have one tool and all you can do is beat on things, you figure like that's the way that you're going to solve it. Lean Six Sigma gives you a toolbox that an F1 pit crew would be jealous of. You have everything at your disposal, but you need to choose tactically what fits best for the situation. Because the tools you use also impact how long your project takes. The tools you choose also can impact who you have to interact with. And we'll talk about this as we go through the actual project management elements. But have any of you ever had a project where you were waiting on someone else to do something and you're not their boss? Most interns face this at every job. Like you're told to do something, but you're not in charge. You can't make them do it. It's not their priority, it's your priority. And so you're just waiting. If any of you guys suffered wanting to get into this class and Kicklighter's class, you heard me say over and over, the registrar hasn't done it yet. We have pushed the system as far as it can go, and we are just waiting for the registrar to assign a CRN. I cannot give you a CRN for you to register for because I don't have it. The process was as far as it could go, and I couldn't do anything further. They don't report to me. I'm not their boss. I just had to wait. So tool selection is not just about, does it work? We also want to say, is it the best tool for the job? Is it the best tool for the job that is the most in my control? How much does it cost in labor hours, in time? These are all things that go into that tool selection. So then we want to make an improvement. And I guarantee you, this is outside your sphere of influence. A lot of times when you come in as a consultant, your improvement is a proposal. You're not actually fixing anything. And that's where these projects, you're kind of functioning as consultants. So your improve and control for your projects can be proposals, meaning you don't actually have to have the improvement done. You can make a proposal on how they should improve it and how they should control it without them actually doing something. So like if you chose something at Barry and you get all of your data, you map everything out, you look at how it should be controlled and how that would work moving forward, and they say, yeah, we're not doing that. That doesn't mean that you haven't done a project. You'd still document your recommendations for improvement and control. So the same thing at like AmeriQual or something like that. If you have a good place where you can collect good data, there's opportunity for a Six Sigma project. Now, if you do something working maybe at Amy Chan Hilton's office, you might be able to go to her and say, here's the improvements I think you should make, and here's how you can control it. And they might go ahead and implement it. Or you're working with Sean over at the library and you say, this is what you can do and how this can function moving forward. And he says, great. And he does it. Like that makes your project a little more robust because then you can document results after the fact, right? But sometimes you can't. Sometimes Sean might say to you, like, that's a great idea. We'll do that next year. They're still going to do it, but it doesn't help you for this class. So because we're looking at this from a consultancy point of view, there's a couple places in the project documentation where we might just make recommendations. And if they can't be implemented, that's okay. Yes.
Like engineering, sort of like classical engineering, sitting down, doing a SolidWorks model, like or like doing research on a different machine that's going to increase your process. What part of the DMA process does that fit in?
So typically that's part of M&A, and depending on what you're doing. So measuring the system, that's drawing up your process map, that's maybe running an FEA analysis on a product, like, right? So you're measuring stuff, you're looking and seeing what's happening right now. Doing research on possibilities, you're analyzing ways to meet the desired goal, right? So that's kind of happening in that M&A process, which is why all of you should be able to get through DMA completely, whether or not the improvements actually happen or not. You can get all the way through that and make recommendations for the improvement. And then if it's outside your control, whether or not the improvements get completed, like that's okay. Because you've been able to do DMA completely, you've been able to make the recommendations for the improvement and control, even if you can't control that part. Does that answer your question? Okay, good question. So the old model that was only 3 Sigma, they really focus on manufacturing processes, where Six Sigma looks at everything. Everything's a process, so we can work on everything, whether it's administrative, logistical, business, manufacturing, service industry, healthcare, Anything you can think of. It's a process, we can improve it. And then the capable process, that traditional calculation for capability, if you've taken McDonald's class, you've looked at a capability index. The traditional 3 sigma process has a spread, that allowable standard deviation of 1/6 of the total spread. To make a 6 sigma process, it has to be 1/12 of the standard deviation of the total spread. So it just shows how much more precise we are in the execution of our process than a 3 sigma method. Now, when we look at how we approach this, we're really being change agents. We're driving some sort of change aspect, which includes changing the way people think, changing the organizational norms, and changing the processes and systems. Now, as engineers, we all drop down to the bottom one and go, yes, that's my jam, changing processes and systems. The problem is that those processes and systems do not stay changed unless we've also changed the norms and how people think. If people think, okay, that's why they're in that order. This is the actual order that you have to adopt. And so we'll spend some time talking next week about this buy-in from leadership and what infrastructure is required. So we're introducing these concepts here. Next week, we'll go into more detail before we start moving into the tools, because all of the engineering tools we think of are that last bullet, the processes and systems. That's what we're actually changing. That's when you get to that measure, analyze, improve, control. But define purely is philosophical. It's a way of thinking. And if people don't think about the system and the improvement the way you need them to, none of your processes will last. So the approach starts with the leadership buy-in, because you're going to need them to put forward training, compensation. There could be new positions depending on how your organization addresses these things. They're going to have to create the infrastructure that allows you to subvert the org chart, because oftentimes black belts and green belts have other positions. They might be part of the continuous improvement team or the quality department, but there's very few organizations that have green belts that are full-time green belts. Black belts, some, master black belts, a lot. But there's very few organizations that have green belts as full-time green belts. Doing a project is kind of alongside your other daily job. And so you're not necessarily in charge of everyone that you're going to be working with. And you need to be able to step outside the normal org chart parameters to execute this project correctly. That's an infrastructure change. That's changing cultural norms. So those things have to happen at the top. That communication and awareness is also from the top. You need to know that you are backed by the highest levels of leadership, so that when you're trying to push this thing forward and people are saying, but that's the way we've always done it, but that will never work, we don't want to, you have someone higher on the food chain saying, yes, you're going to do this. This is what the company is doing. We are moving forward. It doesn't matter that you don't like it. So that communication awareness has to be coming from the very top. You need both stakeholder feedback systems and process feedback systems. The process feedback systems we embed into the Six Sigma process through improve and control, right? Like we have ways of seeing whether or not we've done stuff and whether or not we've done that successfully. That's improve and control. Stakeholder feedback systems are intentional in your project management. And how many here took 417 or in 417 with BAME, project management? A couple of you. Okay. So part of the project management is, where are you getting feedback from your stakeholders to check in with them and make sure that this is happening? So for example, Hunter and Brendan are doing their senior design project, and I am the stakeholder. They have been greatly delayed in receiving their robot, which may in fact change their scope. That's a conversation they need to have with me. Once the robot arrives and they pull it all out and start looking at it, they may come back to me and say, Dr. Ely, I know we had talked about getting X, Y, and Z done, but because of the delays, we can only get X and Y done. That's something I shouldn't find out on May 5th. I should know that now, right? That's that stakeholder feedback that's coming, because you want those expectations of your stakeholders to continually, people should never be surprised when you get to the end of the project and say, we really didn't accomplish what we set out to do, but we did make this improvement. People will be very upset if that's the first time they're hearing about it. You need to keep them in the loop throughout the process. And then the project selection and deployment is the actual physical doing of the project. So other than project deployment, everything else is really conceptual. This is done at the highest levels. It's done very early on. And it's the way that you approach doing the project. Now, the benefit, this was an example that was taken from GE and showed that the cost benefit ratio, as you continue to do more and more Six Sigma projects, they build on each other. And so your costs decrease and your benefits increase. So you continually get more and more benefit, but you lower your cost. Why is that true? So right. Okay. So yeah, so we're reducing costs as we're improving systems. Absolutely, that's true. The other thing is that some of these steps of creating buy-in, of establishing infrastructure, of creating the systems that allow these projects to take place, you don't have to do over and over. You have to do it the first time. Maybe you have to reiterate the second or third time. But once your company is in a culture of doing Six Sigma projects, you don't have to go back and keep rebuilding the wheel, right? You have templates to work with, you have systems to work with, everybody's been trained, everybody has bought into this, people know how this gets executed, and you can really focus on that last step, improving the systems and processes, because you've already changed the way you think and you've already changed the system norms. So the very first project is the hardest and the most expensive, because you have to do all of those changes internally before you're looking at systems and processes. But as an organization has done that more and more, you don't have that resistance and you can focus on those improvements. So your book goes through, and I'm not going to go through all of these individually because we'll talk about them more in the define stage, but I recommend that you go back and look at chapter 1 to review these different roles. This is for a made up company. The ACME is just a made up organization, but it shows the different roles that might be included, and you could potentially need this for your own define stage to kind of say like who's in what role, who's involved. So this gives you a really nice template to look at for your own project to say, kind of, do I have these people? Are they involved? There's one thing I wanted to highlight, and I know you guys have kick lighters starting in 10 minutes, most of you, but he's a patient man. The biggest, this was done, this was a survey that was done of black belts, and they look at the biggest, most influential skill as being able to overcome obstacles. Like the math skills or being data driven, like those are, you need those, but you can also always use team members to help you with that. Like you don't have to do all of that on your own. You work with a team typically. So if you're not the best mathematician on the team, assign it to the best mathematician on the team, have them do the statistical analysis. Really, the leader needs to be focused on clearing out all the obstacles and communication. For the Greenbelt requirements, you can see the industry standard is you're either doing projects on your own every year or you are assisting in other projects. So like ASQ certifies that individuals maintain their credentialing. If you want to have the ASQ certification and maintain that credential, you actually submit proof of doing these projects on specific frequencies. So that's not required for the certification we're doing here, but there are organizations that require that. I want to end on this slide, so don't walk away yet, even though it's 8:50. The biggest reasons for failure: unclear goal, the corporate values do not align with the project values, You come in with a predetermined solution. So you've already decided how you're going to solve the problem before you start, which means you're going to do a really terrible job at measure and analyze because your window of focus is going to be super small. You're going to be working with the solution you've already come up with, and you're not going to be open to seeing what other opportunities are out there. If your scope is too large, or if it's too short term in focus, it's so too large or too small. And then finally, when there's no accountability for people on the project team, for the stakeholders, for the leaders, projects will not be executed successfully. But the biggest thing, top of the list, unclear goals. So define sounds really, really straightforward. It's the first stage we do. We don't spend a lot of time on it because the steps sound super straightforward, but it is the make or break stage. If you don't define things well, then everything else unravels as you go. And so our documentation for define is going to be extensive to make sure that you get set up for success. Because in this class, you have like one project, one chance to nail it. And so we're going to very, very clearly define everything to ensure that you guys have success. All right, read chapter 2 for Monday.